All right, so we have been talking about the different types of functions, right? And so there's 4 types of functions. One type is linear, one type is quadratic, then we have exponential, and then we have absolute value. They all have things in common, and some of them have things that are different. The main thing for this lesson that we are doing is we are learning how to identify what type of function it is depending from a table, right? Why? Because there's 3 ways you can identify a function. There's 3 ways a function can be presented. A function can be presented as an equation. You can look at that equation and tell if it's linear, exponential, quadratic, or absolute value. A function can be presented as a table, like we've been seeing, right? And then from there, you have to decide. A function can also be presented as a graph, where you look at it, right? So if I look at a graph and I see a graph and it's a line, then what is that? Linear. If I look at a graph and I see a U, what is that? Quadratic. If I look at a graph and I see a curve that goes so close to the x-axis but never touches it, what is that? Exponential. Or if I look at a graph and I see a V, what is that? Absolute value. So looking at a graph, I can identify the type of function, right? We can do that, looking at it, right? But the other 2 are a little bit more difficult. Equations are not that bad, but from a table, we have to be able to not only identify the type of function, but we also have to be able to write the rule, right? So for class today, we're not focusing on writing the rule. We're focusing on 2 things. 1, determining what type of function based on what we find from the change in y, right? And then we are going to identify either the common difference, the second common difference, or the common ratio. Everybody got it? Depending on what type of function it is, okay? So let's start with the first one. Give me the, hold on a second. Let me save this. All right, give me the relation. Relation is list of ordered pairs. Give me the list of ordered pairs that we have here.
-2, 8, -1.
So this is -2, -1, 0, 1, and 2, right?
Yes.
Now, what is the range?
8, 6, 4, 6, 8.
When we look at this T-chart, we do not concern ourselves with the X. Why? Because in every T-chart that we've had, the X always changes by 1. Does everybody see that? They're all the same. So what is the bigger concern? The bigger concern here is what is happening to the Y's, right? First thing we always explore is constant difference. Why? Because that's just like when we're trying to find slope. It's the change in Y over the change in X. Well, we know our change in X is, in this case, is always going to be 1. So our focus becomes the change in Y. What is happening to these Y's? So tell me, just looking at this before we do anything else, what function out of the 4 do you think this is?
Absolute value.
I hear absolute value. Tell me why you think it's absolute value. Because it goes down, decreases, and then what? And then it hits a point and increases. So with absolute value, she's saying because it goes down, hits some point. Anybody know what we call that point? That point is called a vertex. It is our minimum. Are you all with me? Are you all listening? What is a vertex? A vertex is either your highest point or your lowest point. In this case, would this be a highest point or a lowest point? How you know it's the lowest point? Because it switches and go back up, right? What is the lowest point that you see here? Which point is the lowest point? 4, 0. This is your lowest point. Why? Because watch this. These are your X's. Starting from -2, going over, right? Where do you start? As I go from left to right, it's at 8, then it's at 6, then it's at 4. Then what happens? Goes back to 6 and back to what? 8. So what is the lowest point on that graph? It's going to be 0, 4. What is 0, 4 then called? It's called my vertex. You're doing notes with me. Let's go. And what is my vertex? My vertex can either be a minimum or my vertex can be a what? Maximum. In this case, my vertex is a minimum. Why am I calling it a vertex? You guys remember in middle school you had something called vertices?
Yeah.
Where you have angles and you have vertices where two things intersect, right? If you look at the walls, where do the two corners of the wall intersect? That's called a vertice. It's a corner. Are you all with me? So what happens at that point? It goes all the way down and then it hits this point and then it does what? Changes direction. So why are we focusing on vertices, or how do we understand what do we understand a vertex to be? A vertex is the point where our line changes direction. It was going down, it hit 0, 4, and then it started to go up. What's happening? It's changing direction. It was decreasing, then it's what? Increasing. Now, we haven't done the math on this, but is it automatically going to be absolute value because it's going down and going up? Or is there another one that it could be?
Quadratic.
What else could it be? Quadratic. This could be quadratic, right? Because what also happens with quadratic?
It curves.
It curves. It hits a point, minimum, and then shifts and changes direction. So it could also go down and then go what? Up. Are you all following me? So this could be, and I love your rationale, my numbers are decreasing and then my y's start to increase. So for me, it could either be absolute value or it could be what?
Quadratic.
What is the difference between the two? That's going to determine it. You guys telling me that both absolute value and quadratic change directions, right? They both decrease and then increase, or both increase and then decrease, right? How are they different then? How are they different? How does absolute value, what shape does absolute value graphs make?
Like
A V. What shapes do quadratic graphs make?
a U.
We call that a parabola. Say parabola.
Parabola.
It makes a U, or some people call it parabola, right? But it's a parabola. It makes a U. What's the difference between the shape of a V and a U? They both got vertexes. They both change direction. They both have that vertex. But one curves and the other one is a what? Straight line. Okay. What makes a line straight? What have we come to learn? What do I have to have in order for a line to be straight? I got to have a what? I got to have what? A constant rate of what? If you ain't got a constant rate of change, is your line going to be straight? No. So let me go back to my question that I originally asked you. What is the difference between an absolute value graph and a quadratic function graph?
One has a constant rate of change.
One is going to have a what? Constant rate of change, because the sides of an absolute value graph are lines. So it's going to have a constant rate of change, then it's going to stop, and then it's going to have a constant rate of change going in the other direction. So it may have like -3, -3, -3, -3, hit its lowest point, and then have what? +3, +3, +3, +3. Are you all with me? Please. Right? Because it's changing what? Directions. So if this is an absolute value graph, I will see what? A constant rate of what? Change. I'm going to see something that's happening over and over again, right? And then it's going to do what? Change directions and go the other way. Are y'all following me? Yeah. If I don't see that, then that makes me think it may then be what? Quadratic. Are y'all following? Yes? All right. What were the three things that I asked you to look for? First difference, constant first difference, a constant second difference, or a constant ratio. So let me explain what the three are. A constant first difference means when I subtract these numbers the first time, something's constant. I see the same change every time. That's just like finding slope, right? That means I got a linear function. Are y'all following me? What if I do that, but I don't see a constant difference? Then I'm going to do it again. So whatever those numbers were, now I'm going to subtract those numbers, and I'm looking for a constant second difference. Are y'all with me? So constant first difference is going to be either linear or it's going to be constant first difference. Lines. It's either going to be linear or it's going to be what? Absolute value. Because if it's absolute value, it'll be the same, but then it's going to change and go up instead of going down, right? Now, if that doesn't work, now I'm going to find the second difference. If that second difference is constant, then we're talking about what kind of function? Quadratic. Then we know it's a quadratic function. Are y'all with me? Okay, my first difference didn't work. Now I'm going to find the difference between these same numbers, these next set of numbers. If that works, then that is going to be quadratic. What if now one of them work? Now what are we looking for? A constant ratio. What is a constant ratio? That means you are multiplying or dividing by the same number over and over again. Are y'all with me? And then that means we now have a exponential function. Is everybody with me? All right, now, looking at this, I think it's either absolute value or quadratic because of the decrease and then the what? Increase. And what is this? This is our what? Vertex. And where does the vertex fall on the V?
The lowest point.
It's at the lowest point or the highest point, depending on what it's doing. If it's doing this, right? Or if it's doing this, right? But where does the vertex sit? In the middle. It's in the middle. So we have what is called a line of symmetry. And it always goes through the vertex. And guess what it does? It splits the V in half. Are y'all with me? If I got a point 3 spaces this way, then I'm going to have another point 3 spaces this way. If I got a point 2 spaces this way, then I'm going to have another point 2 spaces this way. Why? Because this line in the middle cuts that V in half. Are y'all with me? That line is called our line of symmetry. What is it called? Line of symmetry. And your line of symmetry always goes through here. I'm going to write an equation for this. Watch this. This goes through 4. Nope, I'm going to wait. Y'all ready?
Yeah.
All right, so let's do this. What am I looking to do now? I am going to find my change. So let's go. From 8 to 6, what do I have?
-2.
-2. You got to say if it went up or went down. You're working with me. Let's go. From 6 to 4, what do I have?
-2.
-2. I'm going to start right here. What do I think this thing is or could be just based on those two things? What could it be? What kind of function?
A linear.
It could be linear. Why? Because I got a constant
Rate
of change. My first difference looks constant. Y'all with me? What else could it be right now, though? It could also be what? Absolute value. That depends on what happens next. Are y'all with me? All right, so those are my two options. So now I'm going here. What happens?
You're adding.
+2. Oh, what can be eliminated now? Linear. Linear's out. Linear's out. And then from here to here, what do I have?
+2.
Add 2. So based off what we just found, which was that we had a common first difference, right? Everybody with me? We got a common first difference, but that first difference changed directions. It decreased by 2, then it did what? Increased by 2. What does that look like, Stampley? It looks like down 2, right 1. Down 2, right 1. Then what? Up 2, right 1. Up 2, right 1. Are y'all with me? That's a V. Are y'all following me? Yes, sir.
So like if the 2's kept going down like negative, it would have been linear.
If it never would have changed directions, yes, it would have been linear. Absolutely. Is everybody good here?
Yes.
Why? Because a line keeps going in the same direction. It constantly goes down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 1. It's never going to go back up. Lines keep going in the same direction. That's why we know. Okay? That's how we would know. Is everybody clear here?
Yeah.
So what type of function do we have here? Absolute value. Guido, stay with me. We got absolute value. Absolute value. Now describe the pattern. How do we know this was? There's 2 things major that I know we saw. What 2 things did we see? Yes, sir.
The number is turning negative and positive.
So what does that mean? I think you're describing what he's saying. What did you say?
It decrease. It might decrease and after it increase.
Very good. What do we call that? If something decreases, then increases, or increases, then decreases. What do we call that? What is it doing? What are the Y's doing? What's happening to the points? What's happening? Is the direction the same?
No.
Or is it changing?
It's changing.
So then how do we describe that? We did have a rate of change, but what happened to it? Did it stay the same? It did what? Changed direction. We got to see that it's changing direction. It was decreasing, now it's what? Increasing. It's not doing the same thing. So what do we, if we describe this pattern, it was increasing and then what? Decreasing, right? It changed, and I'm just making shortcut notes, changed direction. What else does it have? It has a vertex. Why am I saying it have a vertex? It has a point in the middle that is the lowest or the what? Highest point. So it has a vertex, which is our minimum or our maximum. And how did we confirm it? I see your hand, hold on. How did we confirm it? How did we make sure? Because we had a what? Which difference was it the first difference, second difference, or was it a constant ratio?
First.
It was a first. So it was the constant first difference. That's how we knew. Are y'all with me? Yes? If I see a constant first difference, but it increases and then decreases, changes direction, has a vertex, max or min, this is the absolute value. Is everybody clear? China.
I don't know if it matters, but like, you said increase and then decrease. So
Can it decrease and then increase?
No, because you said increase and then decrease, but like
This-
on here it said decrease and then increase.
So then, what is the question you're posing?
Like, if I say on a paper that, because it said decrease, it said -2, -2, +2, +2. So if I say, and then you said increase and decrease, then it decrease and increase.
So I'm saying it does both. It changes direction.
Oh, okay.
It increases and decreases.
Okay.
Doesn't matter which one came first.
Okay.
It changed directions. All right. Everybody good here? Do we understand how to identify absolute value?
Yeah.
Yes? All right. Let's move on. Let's talk about the second one. Again, we got X and Y, right? Yes?
Yes.
And then we have -2, -1, 0, 1, and 2. All right, what is my range for this one?
-1, 1, 3, 5, 7.
All right. Look at this pattern. And I want you to tell me, what are you thinking it could be? What do you think we can eliminate? What could it be? What could we eliminate? Give me something. It could be linear. Okay. Why?
They stayed in the same direction.
They stayed in the same direction. I didn't see it change direction. What is it doing here? Is it increasing or decreasing?
Increase.
Increasing. So we got a line that's constantly going what? Up. Okay, so this could be that. So if this is that, what then can we eliminate? Absolute value and quadratic, because they both change directions, right? Can we eliminate exponential? Does exponential move in one direction, or does exponential change directions?
One direction.
One direction. So couldn't this also be exponential?
Yeah.
It could be. Because this would be where it is constantly what? Increasing. Are y'all with me? Yes? All right, so let's look at it and see. So what is the first thing I'm thinking to do? What do I always want to find first? The first difference. I want to find the first difference and see if it is constant. Are y'all with me? All right, so let's go from -1 to 1. 2. Now, let me ask you something. What if you are a person who struggles with negatives and don't know? First of all, you got a calculator. You could just plug it in, right? But here's the other thing. You could find somewhere else on the table, right? What is it from 5 to 7?
2.
Okay, so then maybe, let's see, from 3 to 5, what is it?
2.
Plus 2. So then from 1 to 3, what is it? Plus 2. So then I assume that from -1 to 1, it might be what? Plus 2. Are y'all with me? Yes? What did we just, and I'm gonna put this right here, I'm gonna put a 1 above here. Why am I putting a 1 up there?
Because the first difference.
That's my first difference. Looking at my first difference, what do I notice? It's constant. So if I got a constant first difference, and these points go in one direction, they don't change direction, they're constantly going up, then what does this lead me to believe this is? This is linear. This is linear. If I had to find a slope for this, the slope would be 2 over what? 1. The change in y over the change in what? X. But for these, we don't really have to worry about these because they're always going to be 1 apart. So we just look at this part. Is everybody with me? So right now, my constant first difference is what? What is my constant first difference? 2. What was my difference here? It was -2 and what? +2. Here, it is just what? 2. Is everybody with me? Yes? All right, so what is this function?
Linear.
It is linear. It is a linear function. Give me some key features. That word is gonna stand out later. Give me some key features about linear functions. What do we notice? Is it always gonna increase?
No.
What else could it do?
Decrease.
It could increase or what? Decrease. Does it do both?
No.
No. So for the first one, it increases and decreases. For this one, it increases or decreases. Do you understand the difference?
Mm-hmm.
All right. So we're going to put here that this can increase or decrease. Does it change direction? No, does not change direction. What else do we know about this? How did we find it? How did we know that this was definitely linear? What did we do? We look for the first what?
Difference.
The first difference. So the first difference is constant. Our first difference is constant. That first difference is constant. Any questions? Does that make sense? Yes? All right. Let's move on. All right, what's our next one? For this one, we got x and y, got -2, -1, 0, 1, and 2. What is my range for this problem?
1/4.
1/4,
1/2.
1/2,
1, 2,
1, 2,
4.
4. All right. So looking at this, I'm thinking to myself, what can I eliminate? What do you notice about the pattern?
Fractions?
I do have fractions, but fractions are just numbers, y'all.
You're not constant.
It what? It's so you're saying I'm looking beyond them to do a little math and I don't see a constant difference. Is that what you're saying? How do you know that? Because from here to here is how much?
2.
And from here to here is what?
1.
So already that eliminates what?
First
Linear.
difference.
It eliminates the first difference, which means it eliminates what? Linear and absolute value. They're out, right? Why? Because that first difference is not constant, right? If it would have been -2 and +2, maybe that would have been absolute value. But it's up 2 and up 1. That's not linear, not a constant first difference, and it's not absolute value. So that leaves me with what?
Second difference.
Second difference, which would be quadratic and an exponential, right? Which is a common ratio, which means I'm multiplying or dividing for something to be, I'm looking for something constant that way. So let's go through the motions. Let's see what we got. Pull out your calculator because I know y'all struggling. All right, so what am I? Now listen, you can do whatever you want, but you gotta remember, whatever you do, you gotta be consistent, okay? So here's what I'm gonna put in the calculator. Since we always look for difference, then from 1/4 to 1/2, I want to see what it is. Are y'all with me?
Yeah.
You can either put 1/4 minus 1/2, or you can put 1/2 minus 1/4. Totally up to you. It don't matter, but whatever you do, you got to keep doing that. If you put the second number in first, then you got to keep doing that. Are y'all with me?
Yeah.
Let's just go from top to bottom. I'm putting in the calculator 1 ABC 4. Y'all with me?
Yes.
Then I'm gonna put what? Minus, because I'm looking for a difference, right? So I'm gonna put minus what? 1 ABC 2. Y'all with me? Now you're not with me. And what do I get?
Negative 1/4.
So right here, I'm going to put negative 1/4. Are y'all following me? All right, now I'm gonna do it again. I'm gonna go here. Tell me what I'm gonna put in my calculator. 1 ABC 2 minus 1 equals, what do I get? Negative 1/2 now. Okay. I'm starting to see a little bit of a pattern, not really in my differences, but I see a pattern here. 1/4, 1/4, 1/2, 1/2. Y'all see that? Let's keep going. What do we put in next? 1
Minus 2.
minus 2. What do I get?
Negative 1.
Negative 1. It's going to be negative 1. Okay. Y'all see that again? You seeing that little thing happening?
Yeah.
Okay. Let's do it again. What do I do?
2 minus
2 minus 4. What do I get? Negative 2. So from here to here, I get negative 2. Now, we already said, what's this little 1 mean?
the first.
First difference. Is the first difference constant?
No.
No. If it was, we would ask ourselves, did it change directions? Right? Because if it did, then that means it would have been an absolute value. But the fact that it's not constant at all tells us it is not linear, it's not absolute value. So it has to be either quadratic or exponential. So once we check our first difference, now we check our second difference. So let's go over here, since we see the first one's not common or constant. Let's do the second one. So tell me what I'm gonna put in the calculator right here. What do I put in?
Negative 1.
Tell me what to put in my calculator.
1.
1 ABC 4 plus or minus,
Minus 1.
minus 1 ABC 2 plus or minus, because that one's also negative, right? Equals, what do we get?
1/4.
1/4. Okay. Now we can just do this one more time and be good, right? Do we need to go all the way down? No. If we just do it twice and see that it's not, we can stop, right? So let's do it again. What do we got? What am I putting in?
1/2.
1 ABC 2 negative.
Minus.
Minus what? Negative 1. So 1 negative equals, what do I get? 1/2. Now, that was my second difference. Is it constant? Is my second difference constant? Some of y'all look like y'all not sure. Are you wondering if it's constant because it matches this? Because that doesn't determine if it's constant. What determines if it's constant is it the same every time you're going down? Is this constant? No. So that means my first difference wasn't constant. My second difference was not constant. But there is something going on here. Y'all with me? Because I'm seeing a pattern that has developed here. Are y'all with me? And if I keep going, I'm going to keep seeing that pattern, right? I want you to kind of see this pattern. And in the future, when you're working, you start to see this pattern without even have to keep going. I want you to be able to identify what it is before you can find it, right? So that's why I'm pointing it out, because I want you to see there's something happening here. It's not answering my question, but I see something. So when I see this in the future, I'm going to know what it is, right? Let's keep going. First difference, constant or no?
No.
Second difference, constant or no? What's our next step then? If we don't got to do through first difference and we ain't got to do second difference, what do we need to look for? We got to look for a common ratio. And common ratio involves multiplication and division. So what am I going to do now, Miss Stampley? First, let's clear out this calculator. Right? And let's do this. Let's put in our calculator 1/4. 1 ABC 4. And then let's put division. Because I don't know the division. And then let's put what's next. What we got?
1/2.
1 ABC 2 equals. What do we get?
1/2.
Ooh. So this times 1/2. 1/4 times 1/2 gives me 1/2. I'm sorry, other way.
Yeah.
1/2 times 1/2 gives me 1/4. Right? Let's do it again. What are we gonna put in?
1/2.
1 ABC2
Divide.
divided by
1.
1 equals. What do we get?
1.
Oh. What are we starting to see? A pattern. A common what? Ratio. Right? I'm starting to see a common fraction happening here, a common division or a common multiplication, right? What's happening? 1/4 divided by 1/2 is 1/2. 1/2 divided by 1 is 1/2. 1 divided by 2. What's 1 divided by 2? It's not. 1 divided by 2. Sorry. 1 divided by 2 is what?
0.5.
Which is what?
1/2.
It's 1/2. So I get 1/2 here, I got 1/2 here, I got 1/2 here. Let's do it one more time. 2 divided by 4. What do we get? 0.5. But let's change that baby to a fraction, and it's what?
1/2.
So what am I noticing? It's a constant ratio that's happening. I use multiplication or division, and I'm seeing a constant ratio. Are y'all with me?
Yeah.
So therefore, this must be
Exponential.
exponential. This is an exponential function. So right here, type of function, exponential. Give me the key features that we notice about an exponential function. First of all, does it increase or decrease, or increase and decrease? It increase or decrease, but it don't do both. Are y'all with me? What do we see here? It constantly increase. So this is a increase or decrease, but definitely not both. Did it change directions? No. Does not change direction. And then how did we find it? Mathematically using a table. What did it give us?
Constant ratio?
A common or constant what?
Ratio.
We had a constant ratio. And how did we get that ratio? Using multiplication or what? Division. Everybody good there? Any questions? What's wrong? Question? Sure? All right. Now let's talk about this last one. All right. So what do we have here? -2, -1, 0, 1, 2. Again, we got these same numbers increasing by 1. But now if we look at these y's, tell me what the range was.
5, 2, 1, 2, 5.
What do we think when we first see this?
It could be absolute or quadratic.
It could be absolute or what? Quadratic. Why?
Because it has
It's like it increases and
It increases and what? Decreases. It does both. It changes what? Direction. Now, how do I determine? Well, I can eliminate linear because this thing changed directions. I can eliminate exponential, right? Because neither one of them changes direction. So it leaves me with quadratic or absolute. If it's absolute value, I should see a constant first difference. Y'all with me? Going up or down and then change the directions, right? If it's quadratic, then I should see a constant second difference. Are y'all with me? Yes? All right, so let's go. Let's see what we got. From 5 to 2 people. Is it 3?
Yes. Plus 3.
So we're going to add 3. So we going this way or we going this way?
-3. So
To get from 5 to 2, do we increase or decrease?
decrease.
How much?
3.
3. This is very important, Salvador. This part is very important. Head up, pen. from 2 to 1?
Minus
minus
1 to 2?
plus 1
Plus 1. Oh, I see something here. Watch this. 2 to 5?
plus 3.
Now, this is something else that you should pay attention to, right? What's happening? Down 3, down 1, and then up 3. Up 1, up 3.
It curves.
It curves, right? Y'all see that?
Yeah.
It's doing that little, but it's kind of doing the same thing it does here, but I'm noticing a pattern still with the numbers. Are y'all see that?
Yeah.
Right? 2, 2, 5, 5, 3, 3, 1, 1. Where do I see that? Right? Let's keep going. So this was our first difference. Linear? Nope. Absolute value? Nope. Oh, want to be some kind of way, but it ain't working, right? Right? So now let's look at the second one. I want to talk about that for a little bit. It is a little bit like absolute value though, right? Because absolute value goes down, then goes up. This goes down, then goes up, right? And then it's like absolute value because it goes down by the same thing, then goes up by the same thing, right? Except this one goes down by 3 and then 1, and then up by 1 and 3. Are y'all with me? So it kind of reminds you a little bit of it, but it's not because it's not constant, right? It's not the same thing over and over. All right, so now what we looking for? Our second difference, right? Let's see. From -3 to -1, I'm down 3, and then I go up to down 1. I'm 3 below 0, then I'm only 1 below 0. What did I do? Plus 2. I increased by 2. What about from -1 to 1? Plus 2. From 1 to 3?
2.
Plus 2. What do we see?
It's a constant rate.
We see a common or a constant second difference. We see a common second difference of 2. What is our common second difference? 2. Is everybody following me? Yes? So then what type of function are we calling this? This one is what?
Second.
This is what type of function?
Quadratic.
It's quadratic. And why are we calling it quadratic? Because it has what? Give me the key features.
Constant.
It has a constant second difference. Tongue twister? Constant second difference. And we understand difference to mean subtraction, right? Constant second difference. What else? What did we know about this that gave us an idea that it was quadratic before we even found the second
It
difference?
increases and decreases.
It increases and what? Decreases. So this increased and it decreased. Increase and decrease. Does it have a vertex? No. It doesn't have a lowest point or highest point? What does it have?
0 and 1.
0, 1. So this is called our what? Vertex. And is our vertex going to be a minimum or a maximum? Can't be both. You can't be the highest point and the lowest point.
That's the minimum.
It starts at 5, goes to 2, goes to 1, then come back up to 2, up to 5. What is that point?
Minimum.
It's a minimum. It is a minimum. Everybody good? Are there any questions? Y'all ready to practice?
Yes.
Yes. So let's review real quick. How do we know if from a table that a function is linear? It has a what? Constant what? First difference. When I subtract the first time, all of them the same, that's linear, right? I start off and it's linear, and then it switches. It goes from +2 to -2 What is that? Absolute value. What does absolute value and linear have in common? Nobody answer. Ethan. What does absolute value and linear have in common? They both have lines. What makes a line straight? Very good. Y'all clap it out. Excellent. What does absolute value and quadratic have in common? Raise your hand if you know. absolute value, and quadratic, what do they have in common? Salvador. They both have a vertex. Y'all clap it out. That is excellent. Why do they both have a vertex? Because they what? Go ahead. Absolutely. They both change direction, giving them either a highest point or a lowest point. What is that highest point or lowest point called?
Vertex.
It's called a vertex. It can be either a minimum or a maximum. Very good. What about what does linear and exponential have in common? Guido. Linear and exponential. Timothy?
They change direction? No, they don't change direction.
They do not change what? Direction. Thank you, sir. Clap it out for him. Very simple answer. They either constantly go down, decreasing, or they're constantly what? Increasing. Now, we'll talk more about that later. Is everybody clear on this?
Yes.
Yes? So what is our process? We look for the first difference. If it's common, it's going to either be linear or absolute value. We look for that. If it's not constant, then we look for the second difference. Right, Ariana? If that second difference is constant, then it's going to be quadratic, right? If that second difference is not constant, what's my next go-to? I'm looking for the ratio. What operation do I use for that? Multiplication or division. I'm looking to see if I multiplied or if something is divided in order to get me a constant, right? That's how we find those. Is everybody clear? And if none of those work, then it's neither. It's none of them. Is it possible that a graph is none of those? Yeah. Right? All right. Everybody good? Yes. Can you
What would you put it?
stop me? You can stop.